Hello, and we are back. Today we're going to be talking about how to solve equations. To start with, we always want to remember our ultimate goal for solving for equations is to get our variable, which usually it's x, sometimes it's other things, but to get this variable all by itself. And there's different things we can do, different things in our tool belt. The most common of them is by adding opposites. I don't want you thinking about subtracting. I always want you to think about adding the opposite. And again, the opposites are just the other sign of the number. For instance, the opposite of 5 is negative 5. The opposite of negative 4/3 is a positive 4/3. We're just switching the sign and adding that together. Because what happens when we add opposites? Our answer, when we add opposites, is always 0. Things get zeroed out. The second thing we can do is either divide or multiply by the reciprocal. When we divide by something, if we divide 5 divided by 5, 15 divided by 15, negative 225 divided by negative 225, what answer do we always get? This will always equal 1. So here we're trying to get this to equal 1. This is going to happen a majority of times in pretty much all of our equations, and that's usually our last step. A reciprocal, if you remember, is just flipping the fraction. So the reciprocal of, say, 2/3 is 3/2. And what happens when we multiply 2/3 by 3/2? All these numbers cancel out, and again we get number 1. The third thing we can do is distribution. This is where we have parentheses involved. We have to multiply a number over those parentheses to expand it out some. Combine like terms. Those terms with the same variable and the same exponent, or combining those terms are just numbers without any variables, those constants. The last one, and this is probably the most tricky one, is clearing the fractions. It's another way we can solve an equation to make it easier for us. And to demonstrate, we're going to go over several problems. Start with problem A. 5x minus 7 equals negative 17. Now looking at this problem, I see that my variable is on the left-hand side of this equal sign, so I want to get this by itself. Eventually I want x equaling something. Again, I look over. I have this negative 7 that's being added to this 5x. The opposite of negative 7 is a positive 7, so we add opposites to both sides. We end up with, now 5x equals negative 10. We have the 5 multiplying the x, so here we can divide by 5 to both sides. 5 divided by 5, here's our 1x. Negative 10 divided by 5 is negative 2, and that becomes our answer. Letter B. In this problem, we have x's on both sides of our equal sign. Now, again, we're going to come back and think about adding opposites. We want to collect our x's on either the left or the right. Either way, it's your choice. Personally, I like to have positive numbers. So I'm going to look at the biggest number out here. 5 is bigger than 3. So I'm going to bring this 3 over to here. But again, what I have to do, I have to add opposites to bring it over to that side. So the opposite, it makes this negative 3x. And as I add down, again, these cancel. That equals 0. I'm copying down this 8. 5x and negative 3x is 2x. And I copy down this negative 8 here. Now I have x's now on the right side. So I want to get my numbers on the left side. Again, I'm going to add opposites. As you see, we're going to be adding opposites a lot more solving equations. Here we have 16. Now, we're multiplying 2 times x. I'm going to divide by 2. And I get my final answer of 8 equals x. So far, we've only used these first two things, adding opposites or dividing by the coefficient. Now the next few problems are going to be a little bit different. Now if you look at number C on your paper, we have 36 equals negative 8, 2x minus 1. Now, because there's parentheses here, I want to distribute. I want to use this method. Negative 16x plus 8. We end up with that. Now, again, my x's are on the right, so I want to keep them there, so I want to bring the 8 over to the other side. So I'm going to add negative 8 to both sides. 28 equals negative 16x. And now we want to divide by the coefficient. And again, if you notice, I'm dividing by the number that's multiplying the x. I am not dividing by 28 because that's on the left-hand side. These cancel, so I'm left with x on the right. However, 28 divided by negative 16, that's not too easy to divide. So I want to reduce this. Leave it as a fraction, makes it easier. Now it's a negative number. The number that goes into both 28 and 16 is 4. 4 goes into 28 7 times. 4 goes into 16 4 times. And I get negative 7/4 as my answer. If you divided this out, you would get negative 1.75, which again, I would also take as an answer. Okay? Letter D. We don't have parentheses, but we end up having variables on the same side. 9t minus 6 plus 3t equals 6. Now I don't necessarily want to add opposites yet, because as I look at this, on this side of the equal sign, I have the same terms. This is where I can combine these. They are not on opposite sides of the equal sign, so I don't have to add opposites. But I can combine 9t and 3t to get 12t. I still keep this minus 6 equals 6. Now we have a very similar problem to what we did previously in our first problem. I can now add opposites. Add 6 to both sides. We get 12t equals 12. Divide by my coefficient. And my answer is t equaling 1. Now we get to some of the fun problems. The fractions. Now don't let them scare you. There's ways we can deal with them. Problem E. 3/4 x plus 2 equals 11. Now, we have this thing plus x. We're still adding opposites here. This doesn't change. So, we can still add negative 2 to both sides, and we end up with 3/4 x equals 9. Now, instead of dividing, it's kind of hard to divide fractions. This is where we multiply by the reciprocal. The reciprocal of 3/4 is 4/3. So we're going to multiply by 4/3. I know when we multiply by reciprocals, we get x, or we just get the 1, so we're left with 1x. I can now either multiply this out, 9 divided by 1 times 4 divided by 3, or I can do this and look to reduce, and end up with 3 times 4 and getting 12. Okay. You could put this in your calculator again, 9 times 4 divided by 3, and you should get 12. So our answer still ends up being an integer. Letter F. This is the last one we're going to do. 1/2 x plus 2/3 equals 5. Now, we have fractions here. And if we added negative 2/3, we're going to end up with a fraction over there. I want to avoid these fractions. So I'm going to multiply by the denominator of this number here, the one without the variable. I'm going to multiply every single term by 3. 3 times 1 over 2. I can't cancel anything out. This ends up changing to 3/2 x. 3 times 2/3 here. The 3's cancel, and I'm left with just 2. And then 3 times 5 is 15. Now we're back to a very similar problem to what we just did. I'm going to now add negative 2 and put 3/2 x equals 13. And I'm going to now multiply by the reciprocal. These cancel. I'm left with x. Over here, I'm going to end up with 26/3, or if you multiply this out, this would be 8.67 as your answer. Now we will work with more of these. These are a little bit more complicated, something that you're probably not used to, especially over the past year. But we can eliminate some of these fractions by multiplying to clear out the denominator. Now you're due now. This is the problem I want you to do on your own and show me tomorrow. Here's problem G. 3x plus 40 equals 5 minus 2x. There's your problem. Good luck with it. I'll see you next time.